FR4, Printed Circuit Board, Material Explained. Almost every electronic device, from small gadgets like digital watches and calculators to larger systems like computers, communication equipment, and military weaponry, relies on printed circuit boards to connect various electronic components. A printed circuit board, PCB, consists of an insulating substrate, conductive traces, and pads for soldering electronic parts, serving both as a conductive pathway and an insulating base. Among the most common substrates used is FR4. Today, we're going to explore this special material. So, what exactly is FR4, and why is it so widely used? FR4 is a special material designed specifically for flame resistance and durability. The FR stands for flame retardant, while the 4 represents a rating within the NEMA standards. This system was set by the National Electrical Manufacturers Association in the US. This makes FR4 one of the most reliable and widely used choices for circuit boards. Now, let's talk about what it's made of. FR4 is a blend of woven fiberglass cloth and epoxy resin. The fiberglass adds strength, while the flame-resistant epoxy resin acts as a binder. Together, these materials form a sturdy, insulating foundation that can securely hold an entire circuit blueprint. This fiberglass and epoxy combination is typically a 60-40 mix, where 60% is fiberglass and 40% is epoxy resin. Layers of thin fiberglass sheets are pressed together with epoxy to create a strong, insulating base. Once that is set, copper layers are applied to form the circuit paths. So, what are the defining properties of FR4 that make it a top choice for PCBs? First and foremost, FR4 is flame retardant. This property is critical in electronics because overheating can be a risk. The epoxy resin in FR4 is designed to resist ignition and can withstand high temperatures without catching fire. This flame-resistant capability is a major reason why FR4 is the go-to material for PCBs in everything from consumer electronics to industrial equipment. This material also excels in both mechanical strength and electrical insulation. Mechanically, it's strong enough to support various components without breaking or bending under stress. Electrically, FR4 acts as an insulator, which is essential to prevent short circuits. One of the most impressive qualities of FR4 is its stability. It remains unaffected by environmental changes like humidity or temperature fluctuations, making it highly durable for long-term use. With its durable construction, FR4 is designed to last. Its flame resistance, mechanical strength, and environmental resilience allow it to maintain its structure and performance for years, even in high-stress applications. That's why FR4 is a popular choice for PCBs. But here's the thing. When choosing FR4, thickness is a big factor to think about. Thinner FR4 offers more flexibility, useful in devices where space is limited. Meanwhile, thicker FR4 provides better support for heavier components, which is critical for high-power applications. So choosing the right thickness depends on the specific demands of the device you're designing. The industry standard FR4 thickness is typically around 1.57 millimeters or 0.062 inches. This thickness works well for many applications, balancing durability with compatibility for various components. But when a project becomes more complex or requires a higher component count, there are options to adjust the thickness. Now let's check out the factors to consider when selecting FR4 thickness for your PCBs. First up, flexibility. If your board needs to bend or fit into tight spaces, thickness plays a big role. Thinner boards are more flexible, but they're also more fragile, so finding that sweet spot is crucial depending on your application. Next, let's talk about load capacity. For boards that will face physical stress, a thicker FR4 layer offers more strength and better load bearing, making it perfect for heavier or more complex assemblies. Then there's weight. In lightweight electronics, trimming down the PCB thickness can help reduce the overall weight, making your devices easier to carry and more user-friendly. Another important point is compatibility with your components. Some components are more suited to certain FR4 thicknesses. For example, through-hole components usually need a thinner board, while surface-mounted components are more flexible. When it comes to multi-layer boards, the thickness of the FR4 core affects the dielectric thickness, which impacts impedance control. This is critical for high-frequency applications like RF or microwave circuits, where maintaining precise impedance ensures signal integrity. Finally, space efficiency is key. In compact devices like USB connectors or Bluetooth modules, every millimeter counts. Thinner FR4 boards are perfect for saving space and fitting into those tight enclosures. Even with its many strengths, FR4 can sometimes encounter issues that affect its performance. So what are some of the most common defects? First up, delamination. This happens when the layers of the FR4 board start to peel apart, often showing up as bubbles or gaps between layers. It's especially problematic in multi-layer boards and can seriously weaken the board, leading to short circuits or even complete failure. Next, white spots. These can be a sign of trapped moisture or resin pooling. While they might look like small issues, they signal inconsistencies within the layers that could impact performance, especially in high-temperature environments where moisture could expand and cause further damage. Warping is another defect seen in FR4 materials. This often occurs due to uneven heating or cooling during manufacturing, which causes the board to lose its flatness. Warped boards can make it difficult to mount components properly and may lead to connectivity issues when fitting into devices. Then there's blistering. This happens when air or moisture gets trapped in the layers, forming pockets that expand under heat. These blisters can cause delamination or even crack the board, leading to performance issues or short circuits. Cracks can also form on FR4 boards due to stress, temperature fluctuations, or improper handling. These cracks, especially near solder joints or connectors, can disrupt the current flow and weaken connections. You might be wondering, what causes these defects? Well, a lot of the issues with FR4 come down to manufacturing. For instance, if layers are not bonded properly during lamination, delamination or blistering can occur. Similarly, inadequate curing or improper temperature control during production can lead to warping and cracking. Environmental factors like moisture and temperature swings also play a big role. High humidity can cause the FR4 board to absorb moisture, leading to problems like white spots, blisters, or even delamination if the moisture gets trapped inside. Plus, extreme temperature changes, whether from the environment or the device in use, can cause the board to crack or warp over time. Storage and handling practices also play a role. Storing FR4 boards in humid or poorly ventilated spaces can lead to moisture buildup, which causes blistering or white spots. Handling errors, such as bending or mishandling during assembly, can also lead to warping or cracking. As we've seen, these defects can seriously affect a PCB's performance and reliability. If not dealt with, they could compromise the whole circuit board and lead to device malfunctions. By now, you should know that FR4 is a key material in PCB manufacturing. Its flame retardant properties, mechanical and electrical strength, and overall durability make it a staple in the electronics industry. But, like any material, it requires careful handling during production to avoid defects that could affect reliability. If you found this video helpful, hit the subscribe button for more insights into manufacturing. Don't forget to turn on notifications so you never miss out on new content. See you in the next video.